Okay, welcome to this first tutorial for assignment 1, generalized data. The point of this assignment really is to get a detailed mesh model, and we're going to do that using LiDAR data, and this will be done through a software called CloudCompare, which you can see down here as an icon. You can also go into your general search and look for it here, just like that. So that'll be one software that we're using. We're also going to use Rhino, and we'll use the LANDAU LandKit as well. And so this first tutorial really is all about working with site topography. Your site will be your studio site if you have one. If not, we can discuss what site you might use. The very first step would be to download your data, and you'll do this using the Washington LiDAR portal. This is provided in the assignment handout, but it's basically the Division of Geology and Earth Sciences, or Earth Resources. It's their natural resources database. And what I'm going to do just for myself here is type in a zip code somewhat near the school. And for the purposes of this demo, I'm going to use Gasworks Park. And if you're having a hard time sort of orienting yourself with this kind of like DTM hill shade over top, you can start to deselect these, which will make it a little easier for you to actually like look at the map of Washington and get to your site. But we're going to look at Gasworks, and the selection tool you'll use is just on the right here. So this is the select area of interest tool. So you'll give that a click. And then what you can do is just drag and pull, and that'll kind of give you a preview. Let's say you missed part of it. You can just hit escape here and like reorient it. Maybe you want some context and things like that. So you'll click, and this selection tool is just pressing down and remaining clicked down to drag and pull. So once you have roughly the area that you're interested in getting point cloud data for, you can start to take inventory of all these different data sets within the area. Right now we're looking at 20 files and basically 4.5 gigabytes of data. And so we really don't need all this data. We're just going to go ahead and deselect pretty much all of this. And we're going to look for the I would say King County West in this case, 2021. So that's going to be your most recent point cloud data for the area. So make sure you have that selected. And then as you're deselecting the other things, you'll notice the file count as well as, download package size is going to drop fairly dramatically, which is a pretty good thing. So there we go. We're at sort of half a gig of data. In this case, 6 files, which is still quite a lot, but we'll go ahead and hit download. And when we look at this data in Cloud Capture, we'll probably be able to use just a couple of the tiles. My sense is they'll just be different tiles within this region that we selected, which, in some ways, I think you could go in here and, oh, actually, yeah, you wouldn't be able to preview the data set tiles anyway. So it looks like it's done, custom download. So I'm just going to go into my downloads folder, and this is it here. So I'm just going to right click and extract all, and I'm going to keep this in my downloads file. It's very likely that you'll have like a course folder, I would hope, and a kind of assignment 1 folder, and potentially even a data folder or working files folder, something like this, where you'll organize your files a little bit better. And there we go. So in here, you're just going to keep clicking until you get to this area here. So you can see there's 3 different tiles that we're going to look at. These .laz files are basically LiDAR scan files. So in CloudCompare, you can go File, open. And I would recommend just, clicking on the top one, holding shift, and that way you're selecting all three to open. And we can just hit open on these. All these parameters are totally fine. So we'll just hit OK on these. That'll pop up, I believe, 3 times, each time for the different data set, the different tile. So I can kind of already see in the back, that's the one we want, right? So 2578 is really all we need. So these other ones, bear with me here. We're just opening them because we weren't quite sure which tiles we might need. You can see that other tiles like more southern data and a little bit to the west. So it seems to me your files they'll end up here in this kind of data tree, but it seems to me like we can get rid of 2577 and 2505. So I'm just deselecting those and I just want to make sure. Yeah, okay. So for that, you can do the same thing, just, hold shift, select those and delete. So I'm just right clicking and delete. The interface is a little bit different than what we're used to in most drafting software. So to zoom in, I'm still just using the scroll wheel. But what you'll find is there's a lot of pan options. So right now I'm right clicking and I can sort of pan. Left click is going to get you a sort of orbit, some kind of stranger orbit thing. And I'm just using this to start to show you the point cloud data. So right click to pan, scroll wheel. So pretty great data set, very accurate. Really navigating and orbiting doesn't matter so much in CloudCompare, I would say. Most of the time you'll toggle on the side here between this, which is your top view. And oddly enough, this kind of like, although it says front, that gets you to a nice kind of like axonometric view. To select this, you can just click on it. So that's a left click and you'll see this kind of like yellow looking box. So that means you've actually selected the data set and you can start to see here on the side some attributes for what you have selected. In this case, the scalar field, as it's called, is set to intensity. So that's the intensity of the LiDAR scan, which will give you really the closest thing to the real life textures, if you will. And, from there, the first thing we really want to do is we actually want to go ahead and edit the scalar fields because we want to be able to interpret this data. And so again, I'm just going to edit scalar fields. And I'm going to go down here to export coordinates to SF, so scalar field. And the Z coordinate is good, so this is all good. We're just going to hit OK. So I'll zoom out a little bit. And so you can see now that this data set is sort of organized a little bit more by relative elevation. So I'm just doing this toggle just to give you a sense of, the high and low points, grading down towards the water. The other thing that we may want to do right away, because this is a relatively heavy data set, is we could go to our top view and we could start to make some decisions about starting to crop this data set. It's depending on the scale of your project that you're working on, you may not need this much topography or site information in general. So for the purposes of also just like tutorial computing power and things like that, I'm going to go with like Gasworks Park and maybe just this little bit of context for the sort of like adjacent buildings. To start to trim this data set, what you're going to want to do is use this tool here, these scissors. And this is called the segment tool. So just give that a click and you'll notice this kind of bar comes up and automatically you can actually start to click. The one thing that's a little strange is getting used to the additional line work information, you know, like because it just takes a moment to get used to because it previews the kind of closed information. And you'll notice it doesn't end on its own, right? It's not like in CAD or something where you can close this. So to end your line segment, you'll just hit right click. From there, we have a couple different options. Like we could change the attributes, the kind of like classifications of the scalar fields again. In this case, what we're looking to do is actually segment, and we can do two things. We could segment the selected area out of the data set, or we could segment that data set itself. And so what we've drawn a boundary around, we want to segment the inside of that. So I'll just give that a click. And that was this button right here. From there, we'll just go ahead and confirm the segmentation. So the green check mark. And so now you'll see basically on the side here, an additional drop down or drop up rather has happened. So you can kind of read through this and it tells you the latest function, not unlike maybe some GIS programs and things like that. So we want to work with the segmented data set, not the remaining data set. So that's really the very, very first step. From there, we're going to want to split the ground and off-ground data, right? Like part of what we're doing in this first exercise is just creating a sort of highly accurate topographic data set for ourselves to work with. So I'll just go to the front view quickly, just so you can take a look at that segmented out data and what that's starting to look like. So to start to separate out the trees and buildings from the sort of more general ground plane, we're going to want to go into our plugins just up here. And so we're looking for this CSF filter right here. So that's, it stands for like a cloth simulation filter. And so just give that a click. You'll get this pop up. We're all good with the middle one here, relief, but we are going to want to select the slope processing. And we'll just hit OK on that. Shouldn't take too long to compute. So I think I might just sort of pause the video as we wait for this, and then I'll circle back once the loading's complete. Okay, so it didn't take that much longer, but in any case, what you'll see is an additional drop down has appeared here, and you basically have segmented data sets now. So you can see these are your ground points displayed here. And by contrast, if I pick this one, these are the off-ground points. Probably one of the clearest issues with this, is the filter works a lot with just relative elevation. And so at Gasworks, this slope, is actually being registered as either a tree, boat, or built form. So that's just a kind of anomaly in a typical landscape that the computer is not able to account for. So as you might imagine, we can fix this. And so I'll just go through this really quickly using the hill as a demonstration. But you might imagine that depending on your project size, you may actually want to start to segment out buildings from one another or even trees from one another. And so I'll use the hill as an example, but you can imagine this could be done for additional information. So I've, again, just clicked here on this button to get me back to the top view. And you can see right now, I'm not able to select anything. And the reason that's happening is because I don't have anything selected on this side, right? So I want to be working with my off-ground points. So I'm going to go ahead and click that. And you can see now this is starting to get colored in. So do try to remember that, like, depending on what you have selected here, that directly ties to the functions that you're starting to want to work with. So that could be a hang up for you. I just wanted to flag that. So I'm working with my off-ground points, and then I'm going to use the segment tool once more. And I'm just gonna click as much as I can just to encompass that slope. And then don't forget, right click to end that segment. And I'm just gonna do the same thing here. I'm gonna use the segment in tool, and then don't forget to hit the check mark here just to say okay. And so now you can see there's an additional drop down, right? So I can turn my segmented information off, or I can turn the remaining points. So now, for instance, the remaining points you can see, maybe 3D is easier. I've removed that slope. That's now on its own segmented layer. And so what I want to do is combine this layer with my ground points, right? So just to give you a sense here, I'm trying to connect those two. So I'll just use the merge tool for this. So I'm just going to have my off ground points selected as I do here right now. I'm going to hit shift and choose the ground points. And then just up here, there's this kind of like C with or like a rectangle with a block missing, let's say, and how to connect those. And so that's your merge tool. In this case, merge multiple clouds. Give that a click. Do you want to generate a scalar field within the original cloud context? We can hit yes or no. I've actually found that this is the same kind of strange outcome that happens, which basically it merges, but it creates different attributes. So the color actually doesn't matter that much. But what I might recommend is just, again, making sure you have your ground points selected, use the segment tool, make sure you encompass your whole data set, right click to end. And I might just use this, this kind of like scalar field classification tool. So you could just hit that, change your value to 1, let's say, just to make sure those are all the same. And in this case, you're actually just going to hit X instead of the check mark after. So now you can see that's actually part of the topography, right? And we can kind of like orbit around this, check our work. But for the most part, this is really fantastic, highly accurate topographic data. 2 more things I want to show just really quickly here in CloudCompare. One will be to generate a mesh, but we're actually also going to want to simplify these points. What you'll come to see is this mesh model that we'll generate is going to be almost too accurate, and you'll see that a lot better, specifically in Rhino, like the way even the waves get picked up in the mesh model. So what I would recommend just to start is you're going to make sure you have your mesh selected. So here your point cloud selected, and we're going to hover over these dots. And so this is basically to subsample a point cloud. Basically what we're doing here is we're going to simplify the data set. We're going to use randomized spacing throughout the point cloud. And you can see here there's all and none. So basically, as it currently is would be all, none. It's not actually none. It gets you down to 1. So this would be like basically erasing the point cloud. You can push and pull on this a little bit and experiment with it. I'm going to recommend try to do at least, like, from an eyeball point of view, around half. Like you're cutting basically the sample size in half to simplify some of this model, and you'll see it's still going to be highly complicated, but we'll hit OK on that. And so now you can see you have like your more accurate and less. And you can even just by me clicking, you can start to see the density difference in terms of that point cloud. So that form of abstraction is going to be pretty important depending on the size of site you're operating at, right? So if you have, if you're doing a kind of regional studio or something like this, you'll want a fairly simple data set versus if you're doing like, I don't know, a small park or even like in theory, someone's backyard or something, you may be fine to work with like a highly, highly accurate digital scan. So a lot of it has to do with size, and we can talk about that if you have questions. So the final thing we're going to do in CloudCompare is we're going to create a mesh model from this point cloud. So to do that, you're just going to go to Edit, Mesh, and I recommend, they're both Delani Mesh methods basically, but we're going to go with the best fitting plane. So just give that a click. These parameters are fine. And so fairly quick, right? Now you can see, and you can see like some of what I'm talking about as I zoom in, even in this software, like the waves that start to appear for the water. What I imagine, I'm not certain, but what I imagine are people that were picked up during the scan. And so some of that we'll want to simplify, but we're going to do that in Rhino. So for the most part, we're, I think, pretty happy with this. This is our mesh model here. To save this out, it's super simple. It's not even really like an export function. You're just going to make sure you have your ground points subsampled mesh selected. You can go File, Save. And I imagine the default is this sort of like packaged CloudCompare entities. We're just going to want to work with the OBJ mesh for now. So I would just select the OBJ mesh and can name it whatever you like, whatever your working style file naming conventions are. I'm just going to leave it like this for the purposes of the tutorial. And also, I'm just going to save this to my desktop. Again, I highly recommend you have a kind of assignment folder that you're saving this work into. And so it should be a relatively quick export that I can kind of just sort of talk through. And from here, what we're going to do is open this up in Rhino and just start to work with this topography a little bit more. So go ahead and click Rhino. Again, I have most of the icons just in my like toolbar that we'll be using throughout the quarter, but on the off chance you don't have it there, you can just go to your search and type in Rhino and it'll appear. So just waiting for Rhino to load, which is a little bit longer than I would have imagined. Okay. Really quick, I would just recommend, and I'm sure for those that have taken 440, you've talked through some of this, but I would take the properties out and just drop them down here if your default looks like mine, just so you have that. We'll go ahead and go File, Open. And I'm just going to open that OBJ file here. And you'll be able to start, these parameters are all fine, just hit OK. And from here, you'll be able to start to get a pretty good sense of like how dense this mesh model is, kind of assuming that you've worked with some mesh models in Rhino already. So here it is. I mean, you can just tell by the density of the points and vertices. Zooming in here, and you can really start to see these ripples, especially if I go into like rendered view and like start to orbit around. So, you do get highly, highly accurate scan information. What's nice about this working method, in addition to just learning how to work with LiDAR data sets, is most GIS data, you're only going to be able to get like 2-foot contour intervals. This we can set the parameters for, right? And we'll talk through that a little bit. The very first thing though that I want to double check is my units. I also make sure, you're working with a mesh here. So just make sure you have vertex turned on so that you can actually select endpoints and things, because we're gonna want to check our measurements here quickly. Yeah, so we don't want this to be millimeters. We would probably want it to be feet, I assume. And then because it opened in millimeters, let's not scale this model, because I imagine, let's see. Yeah, okay, yeah. So I assume like, what is that? 2,400 feet is maybe a reasonable distance. You know, certainly 2,400 millimeters would not have been even relatively close. So make sure you just double check your units as you're working through that. And from here, I would just really quick, like, start to name some of these layers, right? So this could just be like mesh model original, whatever the logic is that might make sense for you. And then I might just make a new layer, because we're gonna start to create additional data sets from this model, right? So, and I could change the color. Well, maybe we'll keep these black and mesh model can be green. So there we go. So the first thing we'll want to do is use the contour command basically to derive contours from this. So I'm going to switch over, just make sure I'm on contour. I'm going to go over into my front view and just type out contour, enter, and choose my object, enter, and then contour base point. So my base point, I'm just going to select like beyond the model for this. I'm going to hold shift and pull right directly through the model and just click above it, basically. Now it's asking me what the distance between the contours are. So this is where I was mentioning about the GIS data, you know, like if we can only get 2-foot contour intervals there as the most accurate, maybe it makes sense here for us to start to experiment with 1 foot. So we'll do that. And I check my units, so I know I'm drawing in feet. And so we'll let that just compute there really quickly. Okay. So I'm just going to hop into the top view, and you can kind of see the data. I'll turn off the mesh now. And so you can see like again, what I think are people, but I'm not certain. It's kind of the only thing I imagine it could be. Here's the mesh model. It's a pretty good looking model. It's super accurate in terms of like the topography of the gasworks mound and things like that. But what I would recommend here is for us to start to almost like, well, not almost, to manually select some of the outlier information. So like things like these ripples in the water, we may not need those anymore. It depends a little bit on like your own research and studio projects and things like that, like in terms of like how much of this data you may want to actually keep around, right? But what I would recommend is just starting to go through this almost like the way you would do like a tracing exercise, and just hit control for like some of the major contours you want to keep. But you could really start to go through and like, you know, just make some general assessments. This is almost like doing a kind of virtual site visit in a way. Like you're really starting to see what the high and low points are, and effectively the ones I'm choosing to not deselect, I'm going to delete, because those could be, I mean, they're really remnants of noise, you call it, in like the LiDAR scanning. So I think this ends up becoming like a fairly important kind of working method for us as we go through and start to take stock of really the topography, but in a way also the topology of the site. And so I'm going to go ahead and hit pause while I just delete some more of this line work, just to kind of like simplify things out. But I'm not going to make you watch it all. But you know, like these methods here, especially like for the people, like we really do want to start to delete out these to have a more workable mesh as we start to go into some of the environmental analysis and things like that later on. So I'll check back in after I've just deleted some more of these out. Okay, so I've gone through it and just deleted some additional info. We can go ahead and run the script on this to create basically a new mesh model, one that's like somewhat simplified. I think what you'll find that might be valuable is you could even just turn on the mesh once more and just give another couple data sets, like, you know, potentially from like this point of the water over to like this point. Just hit enter and then I'll just hit close, you know, just so you have a kind of plane. This depends a little bit, of course, right? Like you may have files where you have bathymetry and things like that, and you may actually not want to make this kind of like distinction between wet and dry, or like to have it folded into the same thing. So that's kind of up to you, like in your own project and your own sort of worldview as a designer. But in any case, what we're going to work in now, and you do have a link to this, it's the LandKit by LandAU, I think, and then Rhino, food for Rhino, sorry. Yeah, there. So you'll have this link to download it, but this is a tool we'll use a couple times this quarter just to kind of like do different types of scripting. They're not quite ready-made scripts, but it's a really great plugin for Grasshopper. So we just go back here. There is a potential for you if you find this is you know, it's 314 curves, so not too many curves, but they are highly they have a lot of accuracy still in terms of like sample points and stuff like that. So there is a little bit of wiggle room to actually like start to rebuild these contours if you want. So you could experiment with this. This point number would have to be for sure in the thousands still. And we can talk a little bit about that, but I think for now we're going to try and just keep the contours as they are. So let's just hop over into Grasshopper, which is this guy right here, this icon. And so I'll have already loaded LANDAU like into this. You know, I think based on the 440 curriculum, it seems like you've gone over this in terms of like your components folders and things like that. But you can see the LandKit basically gets dragged and dropped into there. So it's going to appear on the top here. So you're specifically today, and maybe, sorry, I'll just do like kind of split screen if I can, just so you can kind of see both things at once. Yeah, it's not necessarily ideal, but yeah, that'll be fine. So again, just up here, you have there's a lot of different things they have. They have like the plant kit, which we'll play around with later in the quarter, but today we want to work with the topo kit. Like I said, they're not necessarily ready-made scripts, but they're pretty much there. So like, you know, you can just hover over these and read them. So, you know, I want to create topo. I want to add a geoset. Okay, we'll go like that. And then I want to draw topo as my output. Those are going to be the three things. There's a couple other ways for you to start to solve for this. It has a little bit mostly to do with inputs and outputs, right? So we have, like I mentioned here, well, it's 309 now. I don't know if you noticed, but I deleted a couple of things off to the side here. So 309 instead of 314 curves. So over here, if I want to input my geoset, my data, it's going to be a curve, right? So for those that maybe are less comfortable or familiar with Grasshopper, just double click twice on your left mouse button thing. And then you can just sort of type in curve. And so that'll pop up. This is the curve. So over here, I have these curves highlighted. And so I'm just going to go back over here, right click. And there's a couple options, right? I can set one curve. Now I know I have 309, so that means it's multiple curves. So there we go. I've set those. You can click on this and you'll get that green preview if you remember. And so now I know that Grasshopper is understanding that I've input these curves and this thing represents those. Here, I'm realizing, yeah, it's not the geo set that we want to put it into. Basically, if you're lost at all, you can just kind of read these things. So like contour curves, like that's literally what I want to do. And you can hover over it and it says contours are elevated curves, open and disconnected, which is really powerful, right? So we don't have to manually model these. We don't have to ensure they're open or closed. So I've just done the drag. I just click down right here and plug that in to this input. From there, there's a question of like, what is the output? And so the output is actually a geo set. So it would be like this kind of thing, short form GT. This topo process basically is what we'll just plug into. And then the output here is the topography instance, right? So in this case, this would be like the kind of mesh. You can think of this as like the mesh command. This thing like organizes the data set. Like this is what ultimately triangulates, I believe, breaks apart these lines. And then this is the triangulation itself. And then here, there's the topo instance to draw. So just plug that in. This might just take a second for it to compute. There we go, not so bad. And so now you can see this preview, right? When I click on this, that's my mesh model. And so this is a good chance for you to kind of take stock of what you've made. You know, I mentioned, for instance, like on the hill before, there were all those like random people looking things. So those are all gone, right? We deleted those out, but still looking really good. Just kind of looking to see if there are any anomalies. This may give us some trouble, right? Like these stacked lines. And we can kind of talk about different ways, almost case by case on how to work with this. But in any case, I like to, from here, the output is a mesh. Now I could probably bake this to create an actual model, right? If you remember, this is just a preview, so there isn't any mesh just yet. So I like to just close this out with a mesh, just to say the output mesh can go here. And again, it's the same thing. Similarly, there's a points output, right? So you could output points. And so there's this sort of funny moment where we could actually generate another like simplified point cloud through this abstraction method that we've done in Rhino through Grasshopper. So in this case, I would just come over here, maybe make a new layer, simplified mesh. Still not that simple, but you know, a little more. I'm going to click on this, right click and bake. I'm going to select simplified mesh and hit OK. And I'm just going to close this and go over here. And so now you can see we've created a mesh that's a little bit more simple. Still has a lot of data, and we can play around with those parameters. But like I mentioned, I mean, you may want to hit Control and Shift and press down. This is like a secondary select. So you could actually do that and like start to delete out some of like these, depending on like what you're after, you know, like you could actually start to delete out some of this additional information that represents, if I go to top view, it might be a little simpler for you to see, but you can start to see like, you know, the water's edge versus like, in this case, let me just hit undo. versus just the triangulation to connect, these points. So that'll be up to you and kind of your own projects, like in terms of like how you may want to delete that information out. More or less, this is the first tutorial for just how to get that base model. You'll be using this even still for assignment 1 to start to do some environmental evaluation using Grasshopper. So you'll do like slope analysis, sun shade, these kinds of things. And we'll also work on modeling some additional information, like just some buildings and stuff like that. But that's more or less it for this very first tutorial, and there'll be a second one for you to kind of start to work with this mesh model a little further.